So I just got, I think that around 4 hours ago, because yesterday evening, so I tried to review the site, and then because it's 2 hour video, so I want to cut it, so 1 hour and a half, and then it's still too big, and then resize, and then the quality is not good, so I have to redone it several times, and each time the decoding or the video processing, it takes a lot of time. So that reason why I only upload the video for yesterday, just around 3 or 4 hours ago.
Okay, yeah. But
So let me know if this is there and it's working properly. Otherwise, so I need to make the convert of the video again, because the maximum size of the video is only 250 megabyte. So this is the limit of the video on Moodle. So now I want to share my screen. On screen share, so I can minimize this one, put it maybe here, and then yes, then this is where we wait yesterday. So we stop at exercise number 21 and exercise number 22, more or less the same. The difference is we just add one more part. Now we have let me have a look on the document. Yes, so now just follow the instruction. So duplicate exercise 21 and rename it. Okay, so after I duplicated, I can simply close this one, rename it to underscore 22. If right, conditional structure, conditional structure underscore if underscore else if. Okay, and what I need to add is insert one more buffer, name it buffer blue, one more buffer, and this is buffer blue, so I can put it here, and then another buffer here, and this is buffer blue. Okay, then what next? And of course, I also need to create the third entity. So this is my, and I think that where should I put it? And I put it here, or maybe yeah, here. No, it's too small. So maybe a little bit bigger here. Yeah, so I have here my MU and park, duplicate this one and F2 to rename it to blue. So this is from the last library, and I want my source also create MU blue, and the quantity of it is 1. So remember, to create different type of MU, we go to MU selection, table, and the table here is data type, data table. You can find a data table here in the information flow. Here is the data table. The format of the data table is like this, but when you connect the data table to this line, and then it will reformat the table for you like this. Okay, Now I need to specify one more MU, and the quantity is 1. The name of it is blue. Okay, so guys, so here it means that I will my source will produce 1 MU red, 2 MU yellow, and then 1 MU blue. Okay, and then I will change this one to capital blue for you to learn a bit. So here in transfer, make it bigger. So the first case is red. If else, move to yellow. And now we have the third case. It means not red, not yellow, it's blue. And then how we do it? We use the else if structure. Okay, so you can modify here, or remember, if you don't know the control structure, you can go here. Okay, it will have you to have the basic organization of the code, and then what you need to do is you just fill up the condition. Okay, for example, I can delete it on and then do it at the beginning. So for someone that not study last time, so you can still follow it. Sorry, so this is then if condition, the first if add dot name equal. Remember, when we compare two value, it's equal. One when you want to set the value, so it will do dot equal. Okay, so be careful with writing your code. Here the name is red. So if add dot name equal to red, then what is the action? We remove the add. Again, S is represent an MU that trigger the method. Okay, so whenever a method is triggered, it will ask, okay, which MU is trigger this method. Okay, and then put the address of that MU to here and get the name of it and do action. Okay, here transfer destination buffer red. Okay, else if condition, this means this one, if this one is not true, this means that the name of the MU is not red, then it will check another condition. What condition? The one that you write on this line. Okay, so the name equal to let's say blue. Okay, and you will see this will be incorrect. Remember, I said here in the data table, the name here is blue with the B capital. It means here, I should also write down here B capital. Okay, when you compare something, okay, it will be very careful because they are the case sensitive condition. So they will indicate, so they will specify is it capital or not, and so on. So at the moment, I'll write here blue, and then you will see there will be the mistake, and then from that you can learn. Add dot transfer, and then the destination is buffer blue. You see the buffer blue here with the B capital, the name of the object. But here in the code, so I just write the normal one. So it's not case sensitive, but when you combine something, so it will be case sensitive. So be careful. So vertical, so maybe this, you can see it. Okay. Then, okay, so if this one is red, move to buffer red. If the name is blue, move to buffer blue. If not this two case, it will move to the yellow buffer. Okay, so that's it. Remember, this is the address of my method. Okay, and then I have a little star at the end. It indicates that this method is not yet be saved. So how I save the method? I press F7. Okay, and then a little star is disappear. And from the last times, you know that to change the color of the MU, you can go to graphic, and then here, blue, and maybe here also blue. Okay, and then now to debug, to check if you do it correct or not, you can press F9, sorry, F9 here in the method. And now I don't need this one. Window vertical again. Then make this one bigger. Yes. Reset. And then now I will explain again the structure of my system. The show here create three type of MU: MU red, MU blue, MU yellow. How it can do it? Because I specify here MU selection. I choose here sequence cyclical. This means that it will follow the sequence and then it will make it at a loop. Okay, and how it in detail here. This is the detail sequence that I specify in the table. The first MU is red. The quantity is 1, and then follow the sequence. It means the next one will be yellow, and then it's 2 yellow. It means that 2 times MU yellow, and then the third one will be blue. Okay, and then it will come back to red because I choose here with the cyclical. Okay, if I just choose here sequence, so it means that it will complete the reaction of one round red to yellow and then blue and then stop. Okay, and I want it to repeat it to generate, so I choose the cyclical here. Then this is the name of the MU is created. Okay, follow this one. Yeah, that's it. A station. The station have processing time of 10 seconds. The control here is mean that at the exit of this station, whenever a MU exit this station, it will call or it will activate the method transfer one time. Again, because I set in the tab control in the exit the connect to the method transfer. So it means whenever MU go inside station and then it go out, before it go out, it will trigger, it means it will open method transfer, run all of the line of code once. Okay, and then finish. And that's it, because there is no connection on the movement or on the transportation of MU will be made by the method transfer. Okay, then now let's run the simulation model. But before that, I need this one. Okay, then let's run the simulation model. Reset, run. And because I press F9 here, it means that whenever this method is activated, it will, sorry, my mouse is not working properly. Okay, then it means it will run. This means a little green dot above the method. It means it's running. And this is the first line of the method. Here you can see, open the anonymous identifiers, and then you will see the add now is the user object dot red, and this is the ID is 3. Okay, and this is the one. Okay, then I will press F11. It means that it will run a step line by line, not step, line by line in the method transfer. Okay, and then let's go to this one, F11. So it will move to here, and because this is correct, so it don't need to check the else if condition, because this is correct. Make this action and skip all of the rest line of code. This means when it's correct here, it jump inside the action and skip this one. Okay, then F11, and now you will see this time the another MU, so it's not the same code, it's not the same event anymore, so it is new event. This is the second time that this transfer method is activated. Okay, so and then in this case, the add now is the MU yellow, not red anymore. Okay, you can see here, and then you can press F11, and then you can see because it's not correct, so it will go to here and ask if it's true or not. And then you will see that this is yellow, it's not blue. Okay, it will not jump inside here, but it will go to the action in the else condition. Okay, F11. This means this is not correct, so it will go to do this action. Okay, and then when I press again F11, so it will move to buffer yellow. And then now you can see this is the third time the method transfer is activated. In this case, the add now is the MU yellow. The ID of it is 4. And then it's do the same thing that it will ask. The name of it is yellow, is red. And then you can see add dot name. See, add dot name. Now yellow is mean this one is false. So it's false, it means that it will not do this action. Okay. And this is also false. So will not do the action here, but the action here. You see. And now I will press F11 again. And now the MU here is blue. Okay, so it will move to here, and because the name of this one is blue with the B capital, with the capital B, so it means this one is not correct, so it will move my part in the buffer yellow because this is not correct, so it will move to here. See, and this is wrong. So how I do the code? So I should make it here the condition with the B capital, or I can change here or here. Okay, so I just want to tell you that the comparison in technometer plant simulation is case sensitive. This means case in mirror. This means that you write big letter or small letter, when you combine it, it will produce true or false according to the capital or not. Okay, and then I will F7. Sorry, I need to put it here. F11. I ask, do you want to change my code? I say yes, and then repeat. And then if you want to skip the running, you can write F10. So it means that it will skip, and then now it's blue again. Now F11 is blue, so each time it will correct and move to the buffer blue. Okay, so if the simulation work properly, so I will press here to deactivate the breakpoint, and now my simulation runs smooth. Okay, maybe a little bit slower. Do you have any questions?
Hi, Mr. Đức. I got some
Yes.
bug and still cannot solve it. Can please help me to take a look?
And then I can stop share my screen. And now it's your turn. Can you open your simulation model? And then we can figure out, so what is the mistake that you have?
Can you see my screen now? Can you see my screen now, Mr. Đức?
Yeah, I can see it.
Okay, so basically it is on the step I follow from your instruction. I put a data table here.
Okay.
I didn't use a capital to avoid the typo or something else. I got the code for the method here. I name it transfer. For the station, I already set up the control select to
Okay.
the object. And
Okay. And then you can set also the F9 and to check step by step. So what is the okay, then you can run this. No, you can just press run, not run step by step, but just run the simulation model, please. Yes. Okay. Right. And then now the add now is user object dot read number ID is 1. And okay, then I think that you haven't saved your method.
I try to resave it. So
Okay, what is the error message? Can I see the
okay.
error message, please?
I will put F7, click F7 to save, but every time I run, it will pop up some alarm like maximum number of calls you change was exceeded.
It's okay. So, but you can now put the F9 again for the first line of code, your code. Yes, F9.
Yeah, I
And
already
run
saved
it.
it.
And
Okay.
then reset the simulation model.
Yes.
Run it. Run. No, just run. Yes. Correct. And then wait until it's open here. And then can you make it? Yes. Can you make it higher so I can see the full of the window transfer? Okay, then I just see one line of code. Okay, maybe yes, you can try to minimize the yes, that's it. Okay, so I can see the full code, and then F11, please. and then it's a red, so it will move to the red. And now and that's it. The
Stop
thing
already,
is
right?
source doesn't move the MU from source to station. Okay, you see the behavior of your system. The MU inside the source is not moved to the station. So it means that the problem is there. So can I have a look inside the setting inside the object? So double click. No, it's not correct. You are choosing the MU. Yes, double click. And then into okay, control please. Go to control. Okay. And then why is stopping there, not moving to station? Can you close it, please? Transfer. And then can you click on the window transfer again? Yes, no, the window, the debug window. The debug window, please. Yes. F11. You press F11.
Yeah, already mentioned it.
And then why it keep. So it's already execute the add dot transfer to buffer red and already move it to buffer red. And then maybe can I have the look inside the buffer red, please? Go to control. Okay, this is a problem. So we don't connect the transfer to the entrance of buffer red. This means when the MU is go inside the buffer red, it will call the method again. So this
Okay.
is the problem that you have. So apply.
Okay. Let I
Okay, and then
try.
maybe on buffer yellow.
Yeah.
It means that remember when I talking about the method is where you write code, and then you need to specify when you want to activate the code. And then we have three ways to activate a method by their name. It means name sensitive method. We have three name sensitive method is init, ensim, and
Actually this
reset.
this is the original error that I'm facing. So I look around for solution and mistake to setting some transfer on the buffer. But
Okay, and
I
then
mean, yeah, this is the original error message that I have
okay, the
seen
method activation is currently haunted,
on.
and therefore you cannot process an event. Of course, you can just simply okay, yes, and then you can reset the simulation model. Reset. Okay, run it again. No, just run the simulation model. You don't need to run because we already set the breakpoint of it. Okay,
Okay.
and then F11. F11. Okay, then F11. No, you click the F11. Close this one. F11. Open the Anonymous. Yeah, F11. And then open the Anonymous identifier, please. The one in purple.
Where is it?
Okay, wait me a second. I will show it to you. Did you see my mouse?
Yes, I see.
Yes. So now the MU that trigger this method is yellow. So it means that it will go to the else
The else.
action.
Yeah.
F11, please. Yeah, correct. Okay. And I think you can remove the break point. Yeah, F9. Press F9 again. Okay, that's it. F11. 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 Okay, and now it's run. It's just a little bit slow. You can faster your simulation model.
Mhm. So not sure why I got the SS message, the error message when I run step by step like this. Anytime I run is calling that's the maximum number of cone chains per second.
No, it will not be happen anymore because you remember when you connect your method also at the entrance of the buffer. Okay, and it means that
Yeah.
this is your sorry, this is your buffer. Okay, and this is the entrance, and this is the exit.
Yes.
Okay, and then again here. So this is the entrance, and this is the exit. Okay,
Okay.
then you go here and trigger this method,
Okay.
and because this is correct condition, so it will make this one. It will activate. It will run this code, and it's run this code. It means that it will move the MU here again, and ask the method run a second time, and because this is correct, and then this is
Okay.
will make the action of this, and then they make it
Okay.
several times, and then this is the message that the cone change. It means that the series of the activation of the method transfer is exceeded. It means that you call it infinity time. You make it as infinity time loop of calling this method. You know what I mean?
Yes,
Again,
I
so
get
it
it.
means that so this is entrance of the buffer. This at this entrance, the MU will trigger this method. Okay, and the action of this method is move, is transfer. Sorry, is transfer the MU to the here. It means the same location, and because it's transferred to here, it will trigger this method again, and then it
Yes.
keep do it like this forever, and that's the reason why it posts this message.
Okay. Thank you. I got it. Thank you very much, Mr. Đức.
You're welcome. And how about the others? Do you have any issue problems with exercise 20 and 21 and 22? And if not, so I want to do it with exercise 23. So exercise 23, so just tell you there is another way to do it, not with if, and else, but you can expect many cases. Just imagine that you can have more than 3 cases. You have 4, 5, or even 6 cases. So you can use the structure like which case. Okay, so we can type here which add dot name. Okay, and the case here is, for example, red. Okay, and the case here is yellow. And then if I need another case here, is blue, capital B. Okay, and the action is dot transfer buffer. Here is red, and here add dot.
Sorry, can you share your screen?
Sorry, I forgot it. Yeah, thank you. Share my screen on sharing. Okay, you see it? Did you see it? Do you see it, guys?
Yes, we can see.
Okay, perfect. And then again, so this is the exercise number 23, where it's introduced another way to do the problem here when you have sorting the MU, red, yellow, and blue. So maybe you have purple, you have cyan, you have white, black, and so on. And here you can use which, and then with the correct case, it will make the action. Okay, so for example, here buffer is yellow, and then here add dot transfer buffer blue. Okay, and maybe you can write here case white, and then transfer to yeah, buffer white, or yeah, buffer white. And of course, this will never happen because I don't have such cases here, but it's good to have some kind of debug. For example, here, so this is for more experienced coder. So what he will doing, he will do else, and in the else, and then he will say, okay, stop, or make a symbol breakpoint here, or simply right here, debug. Okay, it means that if not red, not yellow, not blue, this means that something wrong happened in my system, and here it's just for safety. Okay, and of course you don't really need it. But if you have to write 100 line of code or 1,000 line of code, so it's good to foresee all of the problem may happen. So it means that someone is accidentally creates, for example, another type of MU here, and then this means that we know that there is something wrong with the data table. So this is again, this is for safety when you write 100 line of code, and then you need to foresee all of the scenario. Okay, F7 to save, and now I just need to run the simulation model again, and maybe faster, too fast. Okay, the same behavior, but different approach. Whenever methods is activated, there will be a little dot blue here. Okay, this is exercise number 23. And then exercise number 26 is about the method transfer. So I don't think that this is difficult, so you can do it by yourself. Exercise 26, it's just one line of code, and then add dot transfer, and the destination is the E2. Okay, and then we have the exercise 27 is also the same. So insert, so maybe it's new. I will do the exercise number 27. New model frame. Exercise 27. Insert. to do exercise 27, we need to do exercise 26 anyway. So this means that we need a shoe here, a shoes here, two station. 1, 2. This is E2. This is E1. And arrange. Okay. Connect them by connector. Press holding control button. Okay, not this one. Accept this one. And using method transfer. Transfer. So this is exercise 26. I'm sorry. So how can I connect it? So I'm sorry, I thought that I'm losing my voice. Nice. Hello. Okay. So connect the method transfer to E1. Go to tab control, and then of course I want it at the exit. Choosing object transfer. Okay, and then now I can run my simulation model. See, without the connector, I can transfer the MU from station 1 to E2. And now exercise 27, where I will delete so I will stop my simulation model here. And then now I will do exercise number 27, where I will change the method transfer to insert. Should be here, insert. And then in the code, so now it's insert F7. Yes, and then I need also to change here because it's not transfer anymore, but insert. And then you will see insert means that you put a new MU to here to the E2. And then you will see it's also working. The difference here is, okay, the transfer is will be the length oriented method that consider the length of the MU. For example, you can write here, transfer, double click here, and you press F1. And this is yeah, so they will say that it intended. So it's a rand oriented object. So it means that, for example, you transfer object with the MU have the size, and then if you consider the size or the work qubit of the destination, is it enough place for the MU or not? And then it will transfer gradually this MU to the destination. But the other method is, for example, insert or move. It doesn't care this kind of behavior. But the behavior of the overall behavior of the system is the same. Okay, it means that the outside look the same, but the inside it take the transfer also taking to the size of the MU to the account. And here exercise my piece of advice. So normally from my experience, for my work, so more I always use the move command to transfer or to transport one MU from one place to another place. I always use a move. And this is very rare that we need to specify the size of the MU because depends on the level of detail. Remember, when we're modeling a system, we need to specify the level of detail. And then in the material flow simulation, with the very high abstraction level, and then move it far enough command that you can use. Transfer is mean more detail in the size of the MU and check the size of the destination. Okay, here F7. And then I will run the simulation model, and you see the behavior is also the same, not different. I use move because it's faster to write only 4 letters. And then exercise 28. 28, they said us to build a production line with one E1 and one drain connect by connector, and then produce additional method, call it init, and then the so-called EMU part create at E1. Which means that we don't need this one, we don't need this one. The new method is apply, and this is material flow. This connect to this, and then a new method. This is a name sensitive. This means that it will run according to its name. The name here init, it means that it will run this method whenever we press the run button. Okay, and what is the code for this method? So the method is we create the MU, the type is part, and the destination. The destination is E1. Sorry, I press F1, E1. F7 to save. Okay, remember we can run the method in 3 ways. The first way is simply press F5 manually. First means that run by pressing F5. The second is we use the name sensitive method. This means that we have 3 name sensitive methods: init, reset, and endsym. Init method is mean it will run this method as long as we press run button. Endsym method will run the method at the end of simulation, and reset method will run the simulation will run the method whenever we press on the reset button. Okay, then I will press the maybe this simulation is not too fast, and maybe this is 1 minute, so it take a bit longer. Then run the simulation. So now I will press run or start button, and then you will see this will be created here. What is the exit control? What is it? Okay, you want to stop? Yes, it said that there is a method is connect at the exit, and it's not valid. Okay, so I will run again. You see, it's create, and then go here, and then finish. Okay, because this init method only activate once when I press the start button. So it means that it will create one part inside the E1. After the part is finished, this will go to the run, and then it's finished the simulation model. It don't make a loop. So if you want to have a loop, and then you need to activate another this method, maybe here in the entrance. Don't get in it. Okay, apply. This means that when the MU go here, it will call the method here again, and inside this method, this line of code is running, and this kind of code running. It means that it create another MU here. Then now your MU here finish at E1, and go to here and activate this method again, and then make it as a infinity loop. Okay, let's run. See? Yeah, that's it. So this is exercise number 28. Okay, then now I will move to exercise 29. If you have no questions. Okay, exercise 29. So underscore 29, and this is a for loop. Okay, and there is nothing more than a method inside this model. Inside this, what I'm typing here is for var, and so again. So if you don't remember the structure, the code structure, you can go to edit control structure, and then just choose here for next, and then it will give you some hint so how to write a for loop control for, and then they ask for the loop variable, and here you can name any, but normally we use I, and then it will equal to first the start value. I want to start as 1, and the value, the end value is 10. This means that it will do 10 times the action in between for and next. This means whatever you write here, okay, will be run 10 times. Okay, it means all of the action you write in between the 1 and the third line will run 10 times. Okay, and what is the action here in our case? So we will print what? Print the value I. Okay, and then the next for variant declare I equal to 10, and rather than increasing, I will reduce the I to 1. Okay, and then also the action is print the value of I, and this is add control loop. That's it. And then F7 to save the method, and I need to clear this control. and then I will run the method by pressing F5 and in the control panel, and then you will see the result. Because we use the print command, this means that this will have you will see this here. F7 to say F5 to run, and then you see it will 1 2 3 4 5 6 7 9 10, and then from 10 down to 1. Okay, so maybe I can write here print also just something like this. Clear Z1 and then F7 and then F5, and you can see so 1 hello, 2 hello, 3 hello, 4 hello, and then here 10 9 8 until 1. Okay, so this is a for loop. And do you know so do you have any idea so what is good for the loop structure in the code? So for example, when you working with Excel, for example, you want to look for the specific data in the data table. So it's good to have the for loop to check a single of a cell inside the Excel file, or here in our case is a data table. So this is a more, I think this is what you're familiar with when you're working with Excel. This means that you need to check for the specific data in a column or in a row. So this means that we need a for loop to take a look inside specific row or specific column for finding the correct data. And this is for, so just explanation, the explanation. And then when you work with the further exercise, you will see the real application of this one. And then we have the exercise number 13 about the repeat loop. Okay, it's also the same. So maybe I will create another method here. I double click here, and then I first say a new variable. The name of it is I. The data type is integer, and then the value of it is 0. Sorry. So this is a data type declaration. So it means that not 2 dot equal, but only 2 dot. And then here is set in value. So the first value of I equal to 0. And then my structure is for repeat. Okay, repeat. What is the action? Here I will print the value I, and then I do the sum up of I to 1 equal to the original I plus 1. Okay, or you can say so this is a new I. Okay, and this is a current value of I. And if I equal to 0, the new I will become 1. Okay, and to end the loop, repeat. So I will set until what condition? I greater than 10. This means that it will repeat the action until this condition is true. This means that 0, and then 1 2 3 4 5 6 7 8 9 10, and then it will stop the action between the repeat and the until. So here, clear this one, F7, F5. And then the while loop, I just need to put it here so you can have the overview of the repeat, and then you can compare it with the while. The while is slightly different to the repeat. The action is the same. I plus 1. So, or you can I. So it is the same. So it means that increase the value of I to 1. Okay, but for now, you just simply write I equal to new I plus 1. And then, yeah, so n. So here is the y function. Clear this one. F5. Sorry, F5. And you see the result is the same. The difference between the repeat and the while is if repeat the condition will check at the end of the action. The while will check the condition before the action. That's it. Okay. When you want to do the action and then state the condition, you do repeat. And then if you want to check the condition first and then do action, so it will be while. Okay. And then exercise 32. Exercise 32. So now we have a event controller, a method with the name sensitive reset. It means this method will activate whenever I press on the reset button. Okay. And then I need a material flow or source. And then a line. A line means a conveyor. Okay. A buffer. And then a station. Okay. Actually, this is not the buffer, the normal buffer, it's the play buffer. And to activate the play buffer, you go to the, sorry, move this one. So there is no play buffer in the toolbox. How to find the play buffer? You can go to the manage last library and then activate the play buffer option here and apply. Okay, and now you have the play buffer. So the play buffer is different from the normal buffer. In terms of play buffer is for purpose. It means that you store product for a certain purpose, and the time you store in the play buffer is also count for the value added activities, not but account for the storing or waiting when you have the summary report after the simulation run. Again, play buffer is different from the normal buffer in terms of the processing time, the time that the MU stay inside the play buffer will count for the value added activities. That's it. And the buffer will, and the buffer, the time that you stay, the MU stay in buffer will account for the waiting, not the value added. And then a range. And then I need to connect all of them. Okay, and then now I have two methods. The first method is testful. And the second method will be test empty. Okay. So I need to check the number of MU inside the play buffer. I can use the user interface with the displays, drag and drop this one to here. So this is what we already knew. Okay, and then inside the test full window vertical, and then we write the code to the purpose of the test full method is we to check. So if there is enough MU inside the play buffer, it means more than the capacity. So what is the capacity of it? 8, right? Yes. So if it's 8, and then it will stop the conveyor. This will stop the line here. Okay, and the test empty. Here, the purpose of the test empty is we will check. So if the MU inside the place buffer is decreased until the certain amount, it will trigger the line to transport more MU inside the place buffer. Okay. So now we will write the method for the test empty and test full. So test full, we will wait until. Okay, wait until what? Wait until play buffer. Okay, num MU greater than 8. Okay, and the capacity of a play buffer is 10. So if it's greater than 8, and then it will ask the line to pause. Okay, equal to true. Okay, F7, sorry, F7 to save it, and then test empty. There is another way around. Wait until play buffer num MU less than 2. Sorry, prior 1, and then the action is line pause equal to false. This means that unlock or it means that the line is running again. F7. Okay. Prior here, this means priority. So if you have more than one method running at the same time, you need to specify which method is will run first and which line of code is run second. But normally we just use this is a discrete event simulation. This means that the event of each method will run in the sequence. So this first, this second will vary specified in the list of event. But sometimes when you run many sub-model at the same time, and then in that case you need to specify the priority of the wait until. But at the moment, because you write the method on the same simulation model, it means that they will run with the, if you write this first, and then if you run this first, and if you write second, it will run second. And also it depends on the where you activate the method. And we know that when we want to test full, it means that it's at the entrance of the play buffer. Okay, if it's too much, it means full, it will stop. and then the empty, it will connect at the end of the buffer. It means that after you take the MU out of the play buffer, and then it will check the quantity remain in the buffer. If it's empty, it means that it will activate the line to fill up the play buffer. Okay, now I will connect. It means that I will specify the event or the moment that I want to trigger the method. Here, go to control. The entrance will be test full, and then the exit will be test empty. Sorry. Yep. And remember, I want the MU already go out, so it's mean gear. So it's go out, meaning it's touching the connector and it's moved to the station. So now, yep, I can run the simulation model and see the behavior of the system. You see, this is indicates the amount of MU inside, and until it reduce until 2, and then it will fill up the play buffer again. Okay, so this is on about exercise number 32, sorry. Do you have any questions? Do I need to slow down? Or it's okay?
Mr. Đức,
Yes.
about the just one small thing that about the command line dot pause. I write the line in the line in a capital L and it still work. Is it correct?
Yeah, it's correct. And I just told you when you compare, it means that you make the comparison. So this is matter that you write big case or small case. Okay, but here you not compare, you just set the value. So this they know this is the object line.
Okay, thank you.
Okay, any other questions? Okay, then the question is how I know num_mu, how I know wait until. Normally, when you want to know a behavior of any object, you can go here, press F8, and then you can see all of the attribute, and then you want to know what is the MU that inside, and then you look for the information, and then here you see, so this is the correct one. It made the correct one, so you press F1. Okay, and then this is the answer for you or not, and then you look for new attributes, and of course the more that you do it, the more that you know about the attribute, which attribute that you can manipulate in the simulation model, and from that you can have a lot of type of behavior of the system. Again, F8 is very helpful for you to look up correct behavior or correct attributes. From that you can manipulate the behavior of the system. And here we have some attribute that can be changed, and then some attribute that can only reference or read only attribute. That means that you cannot set the new value for this type of attribute. And then you can have the method. This means that the pose is the method. Okay, so it's not the attributes, it's a method. It means that it's a command to ask the object doing something. Okay, here. So for example, I press here F8 and I deactivate the attribute, deactivate a read-only attribute, and only show the method. This means here I can add observer, I can add watchable attribute, I can create a try number, I can create a new attribute for it. I can create a new icon. I can create a sensor, and I can delete an attribute, and so on. And this is all of the command for that object. Okay. And for more detail how to write the code, so you can press F1 to know. And because that I do it several times, I do it yeah, so I know it some. But if you have some new idea, new behavior, and then you want to capture it, it's good to look up for the new attribute, or you can create your own attribute, your own function. Okay, so this is also be created. For example, you can double click on the line, go to the very last step, user define. I can add new attribute here. For example, the line have the, for example, what is it? Manufacturer, for example, I say here manufacturer. Okay, and the data type is not boolean, but string. Okay, apply. Okay, so, and now I have a new attribute inside my object. So it's manufacturer, so it will be M. Here, manufacturer. Okay, and even I can have a new command, new the line can have what is the conveyor behavior that we normally have. For example, we have urgent stop. For example, and the data type of it is a method line. Yeah, so this will become the method, and you can open this one and say here print, for example, stop the line now. For example, F7. Okay, and then line dot urgent stop. Yeah, urgent stop. Okay, then now I can run my simulation F7 to save the method, and then reset and run it, and maybe also activate the control panel and run the simulation model. Okay, you see, stop the line now, stop the line now. So this is the new command that I create for the object line. Okay, again, the attribute. So this is a built-in object, and of course, built-in object has the built-in attributes, but you can create your own attribute, and then you can create your own command for that object. Okay, that's it. Do you have any questions? So if not, then I will have a couple minutes left for feedback from your side. So do you have any question or any specific exercise that you want me to go through? No? And then I will do exercise 39. So this is important exercise, and I think that this will help you a lot. And then the other exercise that is more or less you can complete it. Just follow the instruction inside the exercise. So exercise, the last exercise for today is exercise 39. So new. Here. Show. And then station E1. Truck. So this is a truck from here to here. So I will make it bigger. So normally a truck is 0.6 and it's orange. So yeah, infinity capacity. Okay, good. And then I have another station. This is E2. And this one is E1. And I have a rain. Sorry. And I connect source to E1, E2 to rain, and in between E1 and E2. So I will have a transporter that run on the truck to transport MU from E1 inside E1 and deliver it to E2. So I need a method. The method name init. So this method will run whenever I click on the run button. And inside this method init, I will create a transporter where I want to create on the truck. Okay, so close it. So for example, I click on the play button. Sorry, the object cannot be used in the. Okay. With the argument list. Okay, and then what is the create? Okay, it means now I create MU, the MU, the type of the MU is transporter, and the location is truck. How I know it? So this is the syntax for the create. Okay, then I press run. Sorry. See, there is a transporter that create at the end of the truck. So I want to create at the beginning. So I press here. It's number 0. So let me check the code again. So the destination, the position is the length, and okay, got it. So here I need to put it in the square bracket. Okay. And what? The argument length is not expected. Let me try one more time. Create destination any, and then it will return the object. Look up for the example, the store, the truck. Okay, like that. Then okay, I get it, because also consider the size of the transporter. If I write here 0, so it will create the transporter outside of the truck. So it's not possible. So that reason why it's not accepted this one. So maybe I need to check up the size of my transporter. So what is the length of view? 1.6. Okay, get it, 1.6. So it means now you should be at the beginning of the truck. See, it's at the beginning because the speed of the truck is too fast, so it will be they go very fast to the end. But now, if I put here, you see the transporter is at the beginning of the truck, and then it travel until reach to the end. Okay, so you can use it at the beginning, or you can say transporter the truck .con .backward equal to true. So here, so because I'm not specify the location of the transporter, so it will create the transporter at the end of the truck. And then the second line in the init, I will say the content of the truck will move backward. So truck.con.backward equal to true. Okay, so again, con here is sorry, well, this one, and inside the truck here, we have the con command. The con command will return the object that inside the object that we are writing the code. Truck.con is mean the content mu inside the truck. E1.con is mean that the mu inside the E1. Source.con is mean that the object that inside the source. Okay, and here I say truck.con.backward. Backward is the attribute of the transporter. So the code will be truck.con.backwards equal to true. Okay, I cannot write transporter dot backward equal to true because they don't understand what is the transporter that you are talking about. Okay, the transporter here is have the when you create a transporter, okay, they have the ID. This is the ID of the transporter, and then you just simply write transporter here. They will say no identifier of the transporter. Okay, let's run the simulation again, and then you will see it. See, unknown identifier transporter. Okay, transporter here, you write here is mean that you reference to the object to the last library, and they are not accepted. So to correct the code, you need to write truck.con. Okay, and I can put the F9 here. Okay, to run the simulation model, and then you see truck.con equal to .mus .transporter, and the ID is 1. Okay, so if you want to write the absolute address, you can write here, not truck.con, but you need to write the full address of this transporter. Sorry, transporter mu.transporter and then 2.1. And it's too long, and then we're not sure that how many transporter that you create in simulation model. So it's always safe to say where is the transporter is located. That reason why I use here truck.conf. Okay. So then the method load, and here is the method unload, and then here load. Then inside the method load will be connect at the end of the asset of the E1. I connect method load here, and I will connect the unload at the end of the truck. Control here, we have the complicated situation where we have entrance, backward entrance, exit, and then backward exit. This means that it depends on the direction of the transporter. And then if you the transporter go with the arrow direction, so it means that this will be the exit and this will be the entrance. If it's backward, it means that it's travel from the right hand side to the left hand side, and then it will become the backward exit, and then it will be the backward entrance. Okay, so now I need to connect my load to backward, right? So you want to load when you have the transporter go here until it touches here at the backward exit, and this will be load, and then go here in this direction and unload when the car touching at the exit. Unload. Okay, again, when the car moving backward, okay, it means in this direction from right to left and touching the very left edge of the truck, and then it will be the backward exit. And then going forward, it means from left to right, and here will be the exit. Sorry, I don't need to connect it here. Yes, correct. And then maybe here I can say print question mark name. Okay, F7, and here print question mark name. Okay, and now I can run the simulation model. So now you can see the different. Sorry, F9, remove. Maybe also clear this one. And whenever the car go backward, touching the here is no longer the entrance, but the backward exit. Okay, we have for the truck not simply entrance and exit, because the transporter can moving forward and backward. So that's the reason why we have 4 cases: entrance, backward entrance, backward exit, exit. And then whenever it's touching the backward exit, it will run the method load. And then you can see, so this is a name of the, because I write here the question mark name, and then the question mark is the object that trigger the method. And the object that trigger the method is the truck. Okay, and then after that I will say truck dot con dot backward equal to false. Run the simulation again. And then you will see after touching this one, say the name of it, and then set the backward to false. It means that if you go forward and touching here, run the method here again, and then the same sequence, I will say dot, or I can simply add dot backward because the MU that trigger the method is transporter equal to see again the object that trigger the method is the truck. The MU that trigger the method is transporter. That reason why I write question mark, and then it will print out the name of the question mark is the truck. The add is the MU that trigger the method. The MU that trigger the method is the transporter. Okay, and the thing that we need to complete is we just need to move the E1 to the car, and after touch this one, we move it to here. Okay, this means that we write before it go, it should take E1 dot con. It means inside E1, and then we move it to where at. Okay, so this means that E1 dot con reference to the object that inside E1. Okay, the action is move. The destination is at reference to the transporter because the transporter is the one that trigger the method load. Okay, F7. See, we move to the car, and then to the end of the load method, we want to unload it, right? So it means that here, before it go back, so it will take the add dot con. This means that in the part inside the car, and then we move it to E2. Okay, F7. And then you will see that will unlock the part to E2. So yeah, E2. So that's it. Do you have any questions? So if not, I wish you a nice evening and see you again on this Saturday where we have a fun exercise. This means that we have some exercise that not inside the cell guided strip. This means that outside of the book, the one that uploaded on the Moodle. So I have external exercise, the exercise that without any guide to how to do it, just questions, and then you can read it, and then you use the code that you the code that you already know, then you apply to solve the problems. Okay, so this is the activities on the Saturday where we will do the advanced exercises. This means only problem is described, not solution. Okay, do you have any questions? If you still have questions, yeah, now is the time. Otherwise, I wish you a nice evening and see you on Saturday.
Hi, Mr. Đức.
Yes.
Yeah, I tried to access Moodle and I saw the record from Zoom online lecture on yesterday, but the page is blank. Can you have to check on?
Blank.
Yeah, from my end, it's
Mhm.
blank.
So let me check Moodle. so slow. Maybe it's the size of the video. Okay, so in meantime, so to reduce the size of the video, so I will stop recording the video for now. Okay.
Recording stopped.
Okay, and this is a Zoom.
Thầy Đức, while we are waiting, can I ask one more question?
Yeah, okay.
So when I run the exercise earlier, it says that avoid cannot accept the method. No.
Yeah, and I told you, so when you have some pronouns in the in the method, in the code, it means that this method is only run together with the simulation run. It means that you cannot run it manually by pressing F5. So you need to run the simulation, and then according to each context, it means that each event, and then we show you what is add and what is the question mark. Again, the inside your code, if you write question mark or add, you cannot press F5 to run that method. This will appear the error message, and the error message is the void is not accepted, because if you not run the simulation model, the code will not know which one that activate the method. So imagine I am the method. Okay, if you run me without running the simulation model, and then I will don't know who calling me, okay, or which object that I belong. But if you run the simulation model, it means that the MU is created at source and move to the station, move to the truck, and then at the entrance of the truck or the backward entrance of the truck, this MU touching the edge of the truck and activate the method. It means me. And then in this case, I understand because I write inside myself the add, the S is the MU that trigger the method. It means now the MU that just touching the truck is reference to the add. But if you run it with F5, no MU is created, no MU is running, no touching at the entrance of the truck. This means no add is void.
Okay, understand. Thank you.
You're welcome. So this is about this is the last one. So it means that I need to connect here to the last one. Yeah, so it's up running. So it just take a little bit time to show because the size of the file is too big. So this is a problem. So here, the correct file is the last one. Override. It's
Mr. Duck,
yeah. Yes.
I can see the video now.
Okay, perfect.
Yeah. Thank you.
You're welcome. Any questions? Okay, so now what you can do in the spare time is you can try out exercise 40. So if you can do it, so it means that you more or less understand the concept behind the software. So if not, it means that there is some missing, there is a gap in your knowledge, and don't worry. I will have you to fill in that gap on Saturday. I will explain it in detail where I have an opportunity to interfere or to interact with your action. So exercise number 40 is yeah, more or less cover all of the knowledge that you can have to become more or less expert in production production system modeling, because it's set of the content is about a machine, the method, and then the more or less control of the transportation. This means that you can have some kind of the sensor, and then when the car touching the sensor, it will move the MU or move the material to the correct location. Okay, exercise number 40, try to do it, and then if you can do it, this means that you are more or less getting the concept of the software. If not, it means there is a knowledge gap that I will have you fill in on this Saturday. Okay, is it clear? Do you have any other questions? If yes, I'm still here until everyone leaves the meeting. And if you have no more questions,
Sorry, Mr. Tuck.
yeah, sorry.
Sorry, Mr. Tuck. I don't know why, but I just refreshed the page again and the video is gone. I don't know why.
Really?
Yeah.
Okay, so then we'll work with that again.
Yeah.
Wait for your next questions. This one. Yep. Well,
I also have one question.
yeah, sure.
So in our case study, according to the project training, so the final step is only the evaluation. So is it compulsory to do optimization step?
Sorry, can you repeat? In your project, is you mean that the projects that I will give you, or
The case
No,
study and
the case study? Which case study you're talking about?
our project?
Our projects, it means that
Yes.
the one that after Saturday. Okay, so
Yes,
it's
the one that we
plan
submit.
for the plan of the course is on Saturday. I will yeah, so try to finish all of the software related knowledge for doing projects and do some advanced exercises. And then on Sunday, sorry, I will do once again the training for projects. It means that on that day, on Sunday, I will do with you simulation of the production system. We call it flexible assembly, where we actually model a factory of 8 workstations, and then the movement in it, and then the optimization of that system. We will do it completely together for this training. And then after that, for those who don't want to do their own projects, or they cannot find any, I will assign more or less similar to the one that I already did with you on Sunday, and then you do it for the rest of the time for the course, mean that until the 2nd of November. Okay, again, on this Saturday, advanced exercises. This means that at the end of the Saturday, you can master the software. And then on Sunday, I expect to do with you projects about a production system. This is a flexible assembly system. From the very beginning, it's been for the first step, classification, target setting, target definition, conceptual modeling, formal modeling, simulation experiment, optimization idea, and then some improvement idea for second run of the simulation model, and then further discuss about the result of the simulation run, and that's it. Okay, and after that, after Sunday, I also post or announce the projects that I want you to do it in group of maybe 5 students. Yeah, and then if you want to do the project, your own projects, of course, you can talk to me, and then together we can formulate a project for you. Okay, I do it because sometimes some students, they said that they are not interested at all in the project that I give. It's not relevant to their production area. For example, I do the project in car manufacturing, and then they more or less do the textile industry or electric device manufacturing, for example. And then because of that reason, so I give you the opportunity to do the project from your own idea. Okay, but neither is the case. So the evaluation will be the same. On Sunday, I also announced the evaluation criteria. So it means that what I will look for rating your projects. Is it clear? Did I answer your questions?
Yes, it's clear for me now. Thank you, Mr. Deng.
Okay, then next question, please.
Mr. Đức, no question,
Yes.
but I can see the video now.
Okay, thank you for your feedback. And by the way, so yeah, did you all aware of that on this Saturday and Sunday, we are not travel until Bình Dương City or Bình Dương Province to have the class. We will meet at, where is it again? Sorry. Where is my phone? We will meet somewhere in
District 10.
10. Yes, correct. Is it 10? Thank you, Mr. Trí, for organizing this room for us. I very appreciate that.
Yes, you're welcome.
Okay, so and sorry, so if I we start the class at 8, right? Or at 9, sorry, on this Saturday.
8:30, and we have 1 hour and 30 minutes for the break of lunch.
Okay, so I will write the email so for everybody in the loop, so be informed about the time and the place. Okay, so I will do it now. So I will write the email for the group to know that. So we will meet this Saturday at 8:30 in the morning, and the address. Oh, I don't have the address now. I don't have the phone with me. So I will write the email later. Okay, any questions? Questions? If you have questions, you can post it on the Moodle. So I received until now no questions on Moodle. So so maybe if you don't have the question now, so you can Yeah, so I don't know if you know that there is a forum for us to write questions, and I think this is a Q&A forum where you can add a topic and ask anything. Yeah, so just simply write your question here, and then I try to answer it within 24 hours. Or you can write me an email. But it's good that for everybody, yeah, can also benefit from your questions, that they maybe your problems or your question also your colleague questions, and it's good that you can also put it on the Moodle platform. Okay, so questions? Sorry that I have not 100% my battery today because I just got the rent. Yeah, go back from Hong Kong, so it's a heavy rain. My district 7 is full of water, so and it is luckily that I can make it today for the evening class on time. But anyway, do you have any questions regard to the organization of the course, regard the theory, regard to the software, regard to the thesis? Maybe one of your colleagues have told me about the attempt to do the thesis in field of simulation. I think yes, it's possible, and then most of the students who want to do the simulation will be supervised by me. But technically, you are under the supervision of Professor Cole, but all of the paper, all of the work will be over by me, and then he will be the one on paper only. But anyways, it's about the organization. But I will very happy if you have the intent for your thesis in field of simulation. It could be some application for your own projects, for your own study, and of course, I, as the supervisor, I will support you to turn something that can accept it in the level of master thesis, because most of the case that I have is you come up with some topic that I think that is more or less as a bachelor thesis. It means that you apply something, you solve a problem. So for example, you use technomatic plant simulation